Hello everyone, in this video we're going to continue with chapter 2, equations, inequalities, and problem solving. So far we went over a variety of sections like linear equations in one variable, an introduction to problem solving, formulas and problem solving, linear inequalities and problem solving, compound inequalities. Excuse me. In this video, what we're going to do is mostly focus on absolute value equations. Remember, if you, for some reasons, you miss any basic definitions of absolute value that we already covered, I would strongly advise you to watch our previous videos in chapter 1. And also, if you still don't understand how to solve a linear equations or a linear inequalities, please log in and watch the previous videos on chapter 2, especially section 2.1 to 2.5. We said absolute value equations, that's the one we're gonna use. Remember, equation is a statement that two algebraic expressions are equal, but when you said absolute value, we can see something in the inside of a parenthesis. I'm gonna use a variable x instead. If you have an x, absolute value of x would be equal to a, which is a real number. But remember, we said about absolute value in itself, -2, absolute value of -2 is 2. Absolute value of 2 is also 2. Negative absolute value of 2 would be -2 because the absolute value is outside. Negative 2 absolute value like this, again, it's going to be +2. But if you have negative absolute value of 2 would still be -2 because everything inside of the absolute value symbols is positive, but there is a negative outside. So not a lot of objectives to push you in this section. We're going to just solve absolute value equations. In terms of definitions for absolute value solving equations or absolute value equations, if we solve equations of the form absolute value of x equal a, we use the equality symbol. So, that's not inequality, that's equality. Right? So it's equality. Equal A. If A is positive, remember, it's absolute value of a negative number, absolute value of a number negative. So you cannot say absolute value of x would be equal to -3. That's not true, right? So we know absolute value of negative of x cannot be equal to -3. So if A is positive, then absolute value of uh, x equal a is equivalent to x. When you have absolute value of x equal a, you either have x equal a or x equal -a, because we don't know what was the absolute value. Remember, absolute value of -2 is 2 and absolute value of 2 is also 2. Now let's see in examples when they ask us to solve that equations and containing absolute value. In order to solve, we need to get rid of these two bars. So remember, these two bars mean absolute value. We need to get rid of it. How to get rid of it? We know by removing the absolute value, we have two separate distinct equations. We're going to have 6 plus 2n equal a positive value a, and 6 plus 2n equal -4. So actually, we have two equations that we need to solve. We need to solve each of them separately. So we're going to go with the first one, 6 plus 2n equal 4. In order to solve these equations, we need to identify our variable. Our variable here is n, so we need to isolate n. Then we need to subtract 6 from both sides. Now, 2n equal -2. We need to divide both sides by 2, so n is equal -1. This is the first answer we're fine. We're not done because it was an absolute value functions. Then we need to solve the second equation from it. So 6 plus 2n equal negative 4. If we subtract 6 from both sides, it gives us 2n equal negative 10. Divide by 2 from both sides to solve for n equal negative 5. So these are the two answers. So the solutions are negative 1 and negative 5. You can write solutions as negative 5 and negative 1. I try to put the smallest value first, okay? And of course, if you try, you can even verify it if you want. You said 6 plus 2 times negative 1 equal what? 6, absolute value, of course. 6 plus, no, 6 minus 2. Okay, so 6 minus 2 is really negative 2, absolute value. So that's 4. So absolute value of 4 is really 4. That's true. Now, if we plug negative 5, we're going to say 6 plus 2 times negative 5. Remember, it's absolute value. 6 minus 10, absolute value. Negative 4 absolute value, absolute value of negative 4 is 4. So we can say either way, answers correct. All right. So that's how we check and make sure the answer is correct for these two. And let's take another examples. Here they ask you to solve. First of all, you need to isolate that 6. You need to add 6 to both sides to make sure that you have the absolute value symbols only on one side. So we're gonna have absolute value of 2x equal 10. If you leave the negative 6 on the left, it will be giantly difficult to solve this absolute value. You need to isolate the absolute value on one side by itself, and then all the constant terms on the other side. Now we're ready to apply the property where absolute value of these two would be either x equal negative a or x equal a. Now we're gonna have the first equation 2x equal positive 10. The second equations would be 2x equal negative 10. So if we solve a, 2x equal 10, we can divide by 2 from both sides. X would be equal to 5. If we do it with b, 2x equal negative 10 divided by 2 from both sides, x equal negative 5. Okay, so we have these two beautiful answers for this one. So we can conclude that solutions is negative 5 and 5. So I would say all. Those are all. Okay, that's all. All. All right. If you're good with that one, we can even go with another examples very quick. We have a few examples of these. So we're gonna have a 7, you see, absolute value of 7x equal to 0. We are looking for all numbers whose distance from 0 is 0. The only number is 0. So you cannot say here that you would apply the property where x would be equal to a and x would be equal to negative a. Look, if you said 7x equal to 0, divide by 7 from both sides, it's gonna be 0. That's the first one. If you said the second one, 7x equal negative 0, there is no negative 0 because 0 is totally neutral. So it's still 7x equal to 0. You divide by 7, so x equal to 0. So the only solution for this one is 0. So we can say solution set is 0. There is nothing else you can find at this level. So that's very important to remember. Another examples we can consider is this one. Again, property absolute value of x equal a, we have two solutions, x equal a and x equal negative a. Now, if we go x over to minus 1 equal 11, that's the first one, and b, we're gonna say x over 2 minus 1 equal negative 11. Let's solve the first one. We're going to solve the first one. First of all, I need to add 1 to both sides to make sure I isolate my x term. So we're going to have x over 2 equal 12. The goal is to get rid of the denominator 2 on the left. How would you get rid of it? Well, easy. We need to multiply both sides of the equation by 2. Multiply both sides of the equation, so you end up having 2x over 2 equal 24. So when you cancel this, 2x equal 24 would be your first answer. Now, we're going to do the same on the right. So if we add 1 to both sides, remember x over 2 equal negative 11 plus 1 give you negative 10. Again, here, we need to get rid of the denominator because we need only x, not x over 2. We multiply by 2 from both sides. Now, it gives us 2x over 2 equal negative 20. So when we cancel this, 2x equal negative 20, second solution. So the solutions for this absolute value equations is s equal negative 24 and negative 20. I try to put the smallest number first. So if you want, you can still go back, plug these numbers into the equations, and then you would see the left side is equal to the right side, and it should be good to go. Other examples you can see in this case is this one. You know, they ask you to solve 3z minus 2 plus 8. Remember, in order to solve it, we must have only absolute value on one side. The problem we have is 8. We need to subtract 8 from both sides. Let's subtract 8 from both sides. 3z minus 2 absolute value equal negative 8. Okay, what's next to do here? Yes, I told you, absolute value is always positive. You cannot take the absolute value of something and to obtain a negative number. So in this case, we would consider this one has no solutions because absolute value can never be equal to a negative number. No solutions. No solution at all. Okay? We said an absolute value can never, I would like to write never very big, be equal, okay, to a negative number. Okay, can never be equal to a negative number. That's absolute value. That cannot happen, all right? Now, you see every time you see absolute value equal to negative number, you know there is no solutions. Now, let's see for this example. This example is like almost the same like the previous one. The only difference now we have an expressions also on both sides, but we still have two equations. The first equations remove the absolute value because we still apply the same property where we said x equal a, so we have two of them, x equal a and x equal negative a. So we're gonna do x minus 3 equal positive 5 minus x. That's a. B, second one, we said x minus 3 equal negative 5 minus x. We still have negative with one and positive with the other one. So you see when we move parentheses, because it's positive, we have 5 minus x. If we add 3 to both sides, we have x equal 8 minus x. If we add x to both sides, 1x plus 1x gives you 2x's equal 8. Divide by 2 from both sides, x equal to 4. This is our first solution. Or if we distribute the negative first, all right? Remember, negative 5 minus x, we need to distribute. It's like a negative 1. It's like negative 1 times 5 minus x. So if you distribute the negative to each of them like this, you know negative 1 times 5 is negative 5. Okay, negative 1 times negative x gives you positive x. Okay, now on the left, if we add 3 to both sides, we have x equal negative 2 plus x. Now let's subtract x from both sides. See, we have 0 equal negative 2. 0 would never be equal negative 2. Those are real numbers. If we either have 0 equal to 0 or negative 2 equal negative 2, that's totally false. So we have only one solution. So the only solution for the original absolute value equations is really 4. So we only have one solution. And doesn't mean all the time we're going to have two solutions. So the solution set is really giantly 4. Hopefully that's helped. In a different video, we will come back for absolute value inequalities. We just do absolute value equations. In a different video, we'll come back for absolute value inequalities. Have fun. Take care.